In this video, we will learn about RC time constant. In the previous video, we saw that in a RC circuit, if we apply a source voltage of E and then we turn on the switch, okay, then the current will charge the capacitor and the voltage across the capacitor, okay, VC, will gradually increase. It will increase and slowly saturate at the maximum value of this. Maximum value is equivalent to the source voltage, okay, the source voltage here, E. If the source voltage, for example, if the source voltage is 10 volt, then the max will be 10 volt. If we look at this curve, we can divide this curve into two sections. Okay, first is these are the two sections. This part we call it the transient, and this is the steady state. A transient is a section where the curve is transiting, it's changing, and steady state is where it's already reached the maximum value and it's saturating. For the steady state, we say that once the curve has reached 99.3% of the maximum value, okay, here if it has reached 99.3% of the maximum value, we assume that the capacitor is fully charged, and after this we consider it to be steady state. Okay, in this example, if 10 volt, then for the steady state, once it reaches close to 9.93 volt, we assume the transistor is fully charged, and beyond that it's considered steady state. Less than that, it's considered transient. So this is the steady state. Okay, this is the time for the capacitor or the RC circuit to reach the steady state. Okay, now if we look at this time, the TSS, the steady state time, and if we divide it into 5 equal sections, okay, 5, we divide it into 1, 2, 3, 4, 5 equal sections, and then we take the time for one of this section. Okay, one of this section, this time is called time constant. Okay, time constant. We write it here. Time constant of the RC circuit, and it's given by this symbol which we call it tau. It's a curly form of a T, capital T. And to calculate time constant is very simple. In RC circuit, the time constant is simply the R multiplied by the C. Okay, R in ohms and C in farad. If we multiply these two, we will get the time constant. And the unit for time constant is, it's time. So the unit is seconds. Yeah, and we can see that over here in this curve, it shows the charging of the capacitor. It takes 5 time constants to reach the maximum value. So beyond this is the steady state. Steady state, this is transient. Okay, and this is your steady state time to reach steady state, and this is your time constant, one time constant. Okay, we can also see the percentage. At one time constant, the capacitor will charge about 63.2%. Okay, in our example, if the source voltage is 10 volt, then here after one time constant it will be 6.32 volt, and so on. You can see this is 8.65 and so on. Once it reaches 5 time constant, it's almost fully charged. Practically, we assume the capacitor is fully charged. After that, it doesn't change much. Okay, now the next thing you need to know is how does the time constant affects the curve. Okay, the time constant shows how fast the capacitor can be charged. So if the time constant is larger, you can see here, if this is the normal time constant, if we increase the time constant, this one is when we increase it. Okay, let me make it bigger. When we increase the time constant, the the capacitor will take much longer time to become fully charged. You can see it's increasing slowly. It will take a longer time to become fully charged. If we decrease the time constant, this case, the capacitor will charge much faster. Okay, so when the time constant is lower, it charges much faster. When the time constant is larger, it charges much more slowly. And we also notice, we also have seen the equation for a time constant R and C. So in other words, in a circuit, if you increase the R, it will the time constant will increase and it will take charge much more slowly. Okay, and similarly, if you increase the C, okay, in this curve of R and C, if the R increases or the C increases, the charging will become much more slow.